Hello everyone, welcome to Coders Camp. In today's video, we are going to see linked list cycle 2. So the input given here is the head of a linked list and we have to return the point where the linked list cycle starts. So now we have already seen the problem linked list cycle 1, which is very similar to this problem, which just asks us to return true if there is a cycle. If not, we have to return false. We are going to approach this problem as well with a very similar approach, but just that instead of finding whether there exists a cycle or not, we are going to add one more step to find the entry point of the cycle. So let's see how we're going to approach this. So here is a given example in the problem statement, and in this problem we have to find two things. The first thing is whether the linked list is having cycle or not. If there is a cycle, what is the entry point? So most of you would have been familiar with how to solve the first part of the problem if you have solved linked list cycle 1. If not, that is okay. So here we are going to use two pointers, fast and slow, that is going to move in different speeds, and if they meet at the same point, then we are going to have a cycle. So the logic behind this solution is purely from cycle detection theorem or Floyd's Hare and Tortoise algorithm that says if two pointers that are moving in a different speeds, then they are going to point at same value if there is a cycle. So using that logic, we are going to have first two pointers, fast and slow. So let's say fast is going to be in green and slow is going to be in yellow, and we are going to move them in different speeds. So our fast is going to move with twice the speed of slow. So if we are moving slow by one pointer or one node, we are going to move fast by two nodes at a time. So let's see. At first iteration, our slow pointer is going to point at the value 2 and our fast pointer is going to point at the value 3. So then at the next iteration, slow moves to 3 and fast moves to 5. In next iteration, slow is going to move to 4 and fast is going to move to 7. And finally, our slow is going to move one step ahead and point at the node 5. And since there is a cycle after 7, fast is not going to move towards null. Instead, it is going to take two steps ahead in the cycle. So now by taking two steps, it is going to point at 4 and then to 5, where our slow pointer has already moved. So here is the point where slow and fast meets, and since they are meeting at a point, there exists a cycle. So hence proved by the cycle detection theorem that there exists a cycle and fast and slow pointer has met, and that solves the first half of the algorithm. And there comes the next question. So how do we find the entry point of this algorithm? So yes, the second part is quite a logical approach. If you understand the distance and little mathematics, you're gonna crack it. So before going into the logic of the second approach, let me explain the solution and then go to the logic. So let's see, we are going to have another slow pointer, which is, let's have that as S2, because the slow pointer is going to move by one node at a time. That's why it is S2. You can name it however you want to. So we are going to move S1 or S and S2 simultaneously by one node at a time, and wherever they first meet is the entry point of cycle. So let's give it a try and then go into the logic. So now for each iteration, S2 and S is gonna move one node at a time. So now S2 is at node 2 and is at node 6, and then S2 is at node 3, and again S moves by one pointer, is at node 7. So at the final iteration, S2 moves to 4 and S also moves to 4 because it is in a cycle. So this is the point we are actually looking for, where the pointers S and S2 meet, and this is the point where a cycle starts, and 4 is going to be our output. So yes, it is very clear that once we move slow and fast pointer at some point, and we are going to initiate another pointer which is start from the head of a linked list, and we are going to move both the pointer S2 and S1 equally until they meet at a point. And when they meet at a point, and that is the starting point of the cycle. So how do we say that? So what is the idea or logic behind this approach? So this is nothing but a simple mathematical logic. You can just solve it using mathematically and crack the logic behind it. So first let's consider the distance between head of the linked list to the starting point of where the cycle starts is going to be x1, and the length from the starting point of the cycle to where our S and F met is x2. So here is where our slow pointer and fast pointer met, that found that there exists a cycle. So let's see, from the starting point of the uh, cycle to that point is x2, and let's have the rest of the linked list from the next to slow and fast pointer met till again the entry point is x3. So why again the entry point? Because consider we are going to move our S from this point to where our cycle starts. That is the distance we are going to cover or move our pointer S going forward in the second part of the algorithm. So from here till where our cycle starts is going to be x3. So understanding this would gonna help you solve this. So now let's see how long is the fast pointer have traveled. So if our fast pointer started from the head of a linked list and stopped at where our slow and fast pointer is, it must have traveled starting from the head, went through the cycle one complete rotation, and then came back to this position to meet S. Hope you're understanding what I'm saying. It is going to start from head and then go to a complete cycle, finishes the cycle off, and then from 4 till 5 it travels again. So the actual distance traveled by the fast pointer is x1, plus from 4 to 5 it is x2. Again it is going to move from x2 to, that is from this position till the starting of the pointer, that is x3, and from again x3 or the starting of the cycle it is going to travel till where it met S. So that distance is x2. So this is the distance fast pointer would have traveled to meet the slow pointer for the first time. So now what is the slow pointer have traveled? So slow pointer would have traveled x1 plus x2. Because it is slow, it is gonna meet the fast pointer in its first iteration instead of taking the complete circle over it. So it is gonna travel x1 plus x2. So how do we make them equal? So now f is equal to 2x2. Sorry, f is equal to 2s. Why? Because since we have moved fast twice the time of slow, fast must have traveled twice the distance slow have traveled at some point. So using that logic, we are going to put x1 plus x2 plus x3 plus x2 is equal to twice that of x1 plus x2. Okay, so solving this, 2x2 plus x1 plus x3 is equal to 2x1 plus 2x2. Just an algebraic formula, we are going to just cancel out the x's. So 2x2 and 2x2 cancels. So now rest is x1, x3 is equal to 2x1. So here 1x1 cancels and here remains 1x1. So finally it is going to prove us x1 is equal to x3. So hope I made some sense. So which is nothing but what is the distance from the pointer S to the starting of the entry point of the cycle is equal to the distance traveled from head to the entry point of the cycle. So this is the logic we finally get. So what are we going to do? We are going to traverse this path x1 by having a pointer S2 at the head, and we are going to travel the path x3 by moving the pointer S from its point to the starting. So we are going to eventually move them with equal speed. So at some point they both meet. So that is the point, actually the entry point of the cycle. So hope I made some sense with this formula and expressions. So it is very simple and a logical approach where we can solve it, and finally we just got an idea. We did not get a solution, we got an idea that the distance from head to entry point is equal to the distance from the where the pointers met to the entry point. So we simply put two pointers to travel from these two pointers to meet at some point, and that some point is our solution. So hope I made some sense. So before going to code, this is going to work in big O of one space because we are not going to use any space. And this is going to work in big O of n log n time. So let's go to the code now. So yes, as I said, we are declaring two pointers slow and fast, and we are going to iterate fast by twice that of how slow travels. So here we are having a point that fast is not is equal to null and fast dot next is not is equal to null, because if there is no cycle, which means our fast pointer will first reach to null. So in that case, we can return -1 because there is no cycle. So if not, if it doesn't meet null at all, then if there is a cycle, so which means we have to find a pointer that where fast and slow meets. So now we have our fast and slow meets at some point. If that meets, then it is the point where we are going to declare another node in the head of the linked list. So as I said, once we declare slow 2, we are going to move slow and slow 2 equally by one node at a time. And when they meet, that is the solution we are going to return. So yes, now they both meet at some point. That is the starting point of our linked list. So we can return either slow or slow 2. They both are going to point at the same answer. If not, finally we are going to return null. So yes, this is it. Let's give it a try. Yes, so let's submit. Yes, we have completed today's problem and it runs in 1 millisecond. So thanks for watching the video. Hope you like this video. If you like this video, hit like, subscribe and let me know in comments. Thank you.